So in the previous lecture, we have learned how we can do the basic column planning. So in this lecture, we shall try to convert this physical model into an analytical model. So first of all, starting with the editor file, we can have the units as meter and kilonewton, and have our first joint coordinates at the location of origin only. So pressing Shift plus K option on my keyboard, and the first grid is at 4.5 meter. So I can take 4.5 meter here, and the second is also at 4.5 meter. And these two joints shall be translationally repeated at 3.5 meter spacing. So I select Z as 3.5 meters, and then this whole arrangement shall be repeated at Z equal to 7 meters. So now we have drawn this particular arrangement here. And to make the thing simple, what we can do is that we can model a basic beam arrangement here also. You should note that we are making the model at the first floor level. That is for this first floor plan, which is at 0.65 meter from the natural grade line or natural ground level. So the next arrangement is that the copy of this. So what we can do to save our time is that we can press Ctrl C, Ctrl V option on my keyboard and select X as 9 meters. So now this arrangement is repeated, and after that we do need to repeat the same arrangement by 1, 2, 3 and 4 times. So we select this arrangement, press translational repeat, select default step spacing as 9 and number of steps as 4, global direction is X. So now we have starting from the office area or hospital area, sorry. So starting from this area, this is the hospital area here, and after that we do need to have 1, 2, 3 and 4 classrooms. So 1, 2, 3 and 4, and after that this area shall be the office area and utility room. So now we have drawn this arrangement, but there is this one thing that we should see here. There is this 0.5 meter gap here. So what we can do in this case is that basically the spacing is from this point to this point is now 9 meter again, but actually the we don't need to worry about this, because this column location is at 4 meter from here. But this arrangement is typical, so this is correct. And after that we do need to model the corridor area also. But before that, what we can do in this area is that we can draw beams here also. So, and again to make the arrangement simpler, what we can do is that we can model beam in this direction also. So to make the thing simple, what we can do is that we can go to geometry, add beam by perpendicular intersection. And again go to add beam option here. So now we have drawn full beam arrangement here. And after that what we can do is that we can model the corridor area also here. So going to the corridor area, what we can do is that we can see the spacing here. The spacing is 2.5 meters here. So we do need to select this whole area here. And all of the columns are being translationally repeated except this particular column, so that we can take care in the later section. But to proceed further, we can press translationally repeat at 2.5 meter spacing. And after that, similarly we can draw this area also. So we do need to have a 1, 2 and 3 and 4. But to make the thing simple, I will request you to undo it. Please don't add beam at this point. The reason I will tell you in the later stage. But just model the column first. So these are the columns that we do need in our structure. And after that, just select this arrangement here and translationally repeat along Z as 2.5 meters. So number 1, 2, 3 and 4th. So first, second, third and fourth. So this particular column needs to be shifted by 0.5 meter on the left. So what we can do is that we can delete the beam here and select this node and go to geometry, move, joint and select X as minus 0.5. Select retain connections here. So now we have shifted the joint along X direction. And after that, these particular 4 columns do need to be translationally repeated at the spacing of 4.3 meter, that is 2 meter here and 2.3 meter here. So selecting these particular columns here and selecting axis as Z, default step spacing 4.3 meter and link steps. So now we have all the joints at the column locations only. And after that, there are no columns here. And on this area, we do need to model the ramp area also. So what we can do is that we can select the joints here. And we do need to copy paste at 4 meter spacing. So selecting Ctrl C, Ctrl V option on my keyboard, select X as 4. And we do need to 2 columns here also. Add the spacing of 2.2 meters. So selecting Z as minus 2.2. And selecting this joint also, add the spacing of 4 meters. Similarly for these 2 points also. And this grid spacing is 2 meters. So we do need 2 columns at Z equal to 2 meters. So now we have modeled the ramp area also. So this is the simple geometry of the structure that we are making. So now basically we have modeled the columns. Model the columns in the sense that wherever there are columns, we have a joint there. So what we can do in this case is that, like in this elevation, the first floor plan is at 0.6 meters. So let us say if we want our foundation at 1.5 meter below the natural grade line, that is NGL. So the height of the column shall be 0.6 plus 1.5, that is 2.1 meter below the like first floor level to the foundation level. So selecting translation repeat, so selecting global direction as Y and default step spacing in minus 2.1, and selecting link steps, we can see that we have now modeled all the columns here. So this was just a simple exercise to like model the first floor level. So now you can easily understand what exactly was the purpose of selecting like only columns here, so that we can easily translationally repeat all the joints in the minus Y direction with the spacing as required. So now we do need to model this second floor plan. So now there are 2 approaches as done by the like most of the people. One approach is that they just model the whole structure, and then after that they assign the properties. Second approach, or like smart approach that we can take, is that we can assign the properties here, and then we can just simply translationally repeat them to save our time. But following the first approach only, because I don't want you to get confused. So what we can do is that we can make the whole model first, and then we can later on assign the properties. So coming back to our model, now we can easily check that whether the modeling we have done is correct or not. So as far as I can see, the modeling is correct. So now this whole arrangement, that is at the first floor level, this whole arrangement needs to be at the 3.5 meter level also. So coming back to our model here, so what we can do here is that either we can model the beams along this direction also. The reason for modeling beams along this direction is that we do need to break the slenderness or the axis of the column along this direction here. So I shall already advise you to make this beam here. And we can make the beams here also. See, a good structural engineer will always tie the columns as much as possible, because he know that as much as we tie the structure will be more economical and integrated in the at the time of the earthquake. So what we can do right now is that we can translationally repeat the whole structure. Selecting global direction Y and default step spacing, as we know that the height is in the range of 3.5 meters. So select default step spacing as 3.5 meters and select option of link steps. But we do need to delete the step column that we have modeled here. So here you can see that there is one small step column. So delete this particular column here, and now we are done. So on the plinth level, if we want to see the structural arrangement again, now the arrangement is okay, but the thing is that this column is not getting tied in this direction here. So what we can do is that we can provide alternate ties. So we can go to add beam by perpendicular intersection. So we can provide alternate beams here. As on the plinth level there shall not be any structural slab, but by making this beam, what we are doing is that we are breaking the length of this column along this axis, so that the reinforcement shall be less, and all these beams shall need to be released at the end point. So we go to specifications and we go to beam, start, end, my and mz. So now we have released the beams on the on this point. By releasing, what we mean is that at this point there shall not be any moment transfer capacity, only shear force shall be transferred from this beam to this beam. So for this beam also the case shall be same. So now we have made a fully satisfying model at the first floor level. After that, if we go to the second floor level, we do need to provide the beams here also. The reason for that is because our span is approximately in the range of 4.5 to 7 meters. We shall make the slab very heavy. So to break the span and to tie the columns along this direction also, so we go to geometry, add beam by perpendicular intersection. So by making all the beams here, we can just tie our structure. So now we can see that in the plan view, the spans of the slab are less. That is in the range of 3.5 to 4.5 meters, which is not a very big deal for slab design. And for ramp, as I had discussed with you earlier also, that I shall not be modeling the ramp here, but to make sure that the ramp loading is being considered, what we can do is that we can provide a full floor slab here, and then we can apply the loads so that the columns and the foundation shall be designed accordingly. But if you want to do the fine-tuning exercise, or if you have sufficient amount of time, then what we can do is that you can provide a cantilever beams on all the columns along the ramp profile. But as that was a time-consuming approach, so to make the thing simple, I am following this approach. So coming back to our model here, so now we have modeled the second floor plan also. After that, we do need to model the third floor level. Now we are standing at this particular level, second floor level. So after that, we have third floor level also and fourth floor level also. But third and fourth are just a copy of second floor plan. So in this case, what we can do is that we can just translationally repeat this whole structure along Y. Default step spacing is 3.5 meter and number of steps is 2. So now we are standing here. That is first floor level here, second floor level here, third floor level here, and fourth floor level here. After that, we do need to repeat the arrangement on the spacing of 3.2 meters. So in this particular case, what we can do to make the thing simple is that just translationally repeat this whole structure along Y. Select default step spacing as 3.5 meters, link steps. Select all the beams here, go to geometry. Geometry, move, joint, select Y as minus 0.3 and left click on retain connections here. And now we can see that this is 3.2 meters. So this was just an approach to save the time, and that we have already saved with the help of this approach. But overall the modeling has been done, and in the next lecture we shall learn on how to give the properties and how to assign the floor loadings. But before that, I shall teach you about the basics of the Indian standards loadings. That is, what are the codal guidelines on the loadings that needs to be applied on the school buildings.